many of you never have any problem at all mixing exactly the color that you want? That's why we paint, right? Because it's so darn easy. Okay, so I'm going to give you a couple little things, and part of the reason that it can be difficult is that we don't know enough about the chemistry of paint. And we're going to start, I'm going to make it very simple once again, only because that's how I like it, is that we first have to understand that there are two families of pigments, and they have different properties. And the different properties kind of dictate how you use them. In other words, if you just sort of blend everything together, you're going to get something that is going to work every now and then, and a lot of times you're just sort of like settling for it. So what are the two families of pigments? Well, they're going to be called mineral and modern. Mineral family, we're all pretty familiar with. Those are the cobalts, the cads, all the earth colors, anything that sounds like it's been dug from the earth. All right? Those are the mineral pigments. And its properties are let me say about Golden, I don't know really about any other company. But when Golden makes their paint, they'll take the pigment, very expensive stuff, and it'll get loaded into the binder, right? They'll load it into the binder until you cannot load anymore. Paint says stop, it becomes something else, all right? But Golden will put as much pigment into the binder as the binder can physically handle. Now, each pigment gets accepted in varying amounts, right? So, the mineral family has a tendency of accepting a little bit more pigment. Because of that, it has a much better coverage. It is much more opaque in nature, right? And that's because there's more pigment in the paint. Now, the modern family are, I joke around and say, if you cannot pronounce it, it's in the modern family. If it sounds like it's been created in the laboratory, it has. Like the acrylicmediums, the dioxine purples, right? Those sound like chemistry names, and that's exactly what they are. They've been developed in the laboratory to replace pigments that need to be replaced for various reasons. And I'll talk more about the science of that and the development of new pigments in a bit. But the modern family, it has a tendency of when it's being loaded into the binder accepts a little less. Because it accepts a little less, it has a tendency of being much more transparent. It also has a tendency of drying much to a higher sheen, where a lot, the mineral pigments have a tendency to be much more matte. Once again, because there's more pigment and less pigment in the mineral family. In the modern family. Now, being that it's more transparent, it has a higher tinting ratio, which means how much it affects a color when it's mixed with another color. So, we're going to see some examples. But this is what sort of separates. We all know what color theory is, right? We have the three primaries, red, yellow, and blue. We mix them together, we get the three secondaries, green, orange, and purple, and life goes on happily ever after until you actually start painting. Why? Because that is a theory. There's an abstract set of rules that if you do this, you're going to get this. The problem is, what stops us is what's known as pigment reality. What actually happens when you mix the colors. You have color theory, pigment reality. And we need to understand a little bit about both. Now, the other thing that messes us up with color theory is that we actually have very strong opinions about what those primaries should be. And that's the beginning of the downfall. Right? Color theory. It says a red, yellow, and blue, not a specific red, yellow, and blue. Very important. So let's look at some. Now I said red, yellow, and blue, and chances are you've pretty much thought of something that are colors along this line. Give or take, right? These are all the mineral. You can see how it goes over the black line, how pretty opaque it is. If I hold it like this, you can see it's got a pretty matte finish, right? Okay, now we're going to hop to the modern. And this is where you have to open your mind and just let it be a red, a yellow, and a blue. This has to be in the family. So here's some modern primaries. We have quinacridone, Should love that word. How long it took me to learn how to say it. Quinacridone magenta, we have Hansa yellow medium, and phthalo blue red shade. That's the actual name. Goes down over the black line. I don't know if you can see that. It's pretty transparent. And you can see how much more shiny it is, right? Now look here. Look at how different the undertones are from the mass tones. These are pretty similar. But here, you really get some very different things in the undertones. Right? So the magic happens when you go mix the secondary colors. Now let's say, do you have some really nice, expensive, like Italian and French paints here? You know, the ones that get up to $200, $300 range? Yeah, okay, all right. So let's say, you know, a nice uncle gave you $500 and you want to come and mix your perfect purple, right? Or violet, whatever you want to call it. So you come over here and you go and you go to some French paint and you pick up a nice $250 tube of ultramarine blue. And we're not talking a large tube, typical size. Okay? And then you walk over to the Italian section and you get a nice tube of cadmium red medium. Then you just spent $500, roughly speaking. You're going to wind up with a nice color, right? Not necessarily, because that is pigment reality. So we take these two colors and we wind up with this lovely shade of brown. Color theory. Now, look at these two. Look how intense that violet is. All right. The important thing to remember here is that one family is not better than the other family. It's just how you choose to use it. A lot of people find that the modern colors are just way too strong, and I'll show you a way of kind of bringing them back a little. But what's happening, think of this as operating much more like a computer monitor, because the colors are so transparent and it's on the white. When they're mixed together, they don't neutralize one another. You get a much more clean blend or a tint of the color. So you'll get a much cleaner secondary color. Where over here, being that they're so opaque, what's happening is they're fighting each other. So the colors are going to be much more muted. Once again, there's nothing wrong with these. If you're painting much more naturalistically or from nature, you know, perhaps you want to have most of the mineral pigments. But what if, you know, in the landscape you're painting, you want a nice hot orange poppy that you want to mix? Maybe that's when you have a couple of tubes of modern. Right? So it all depends. Or, you know, going the other way, let's say you work really large, colorful abstractions, you know, that are very transparent, you know, thin layers of color on top of one another. You know, that's where the modern pigment may come in handy. Or better yet, get it all. I'm not going to go back. So, okay, that's a little bit about that. I mentioned that Golden has a bunch of hues. These are all made up of more than one pigment. They all have good, strong light fastness testings. They're just designed, you know, to replace. This is what's known as a historic line. So they are all hues, but they're designed to replace certain colors. Like, for instance, and I have to go back and talk a little bit about the whole science of the development of new colors. So let me say it right now. It's really been sort of like the 70s, maybe the 60s that kind of started in, where two things started happening. There's a lot of research starting to be done on health and safety in the studios. Why? Because artists were dying, and people started saying, hey, maybe we should look into this stuff. What are they using? And then, that, and then the development hand in hand of new pigments to replace a lot of these old colors. And the biggest reason new pigments have been developed is, one, health and safety, you know, toxicity of certain colors. The biggest reason probably is light fastness. Much more knowledge has been out there and testing of it, so colors have been replaced because they're just not stable. And finally, scarcity. Like, you just can't find some of this stuff anymore. You know, it's all been mined. So there has to be a big development in the science, and there's always, every year, there's some major article and some major paper how some art restorers are trying to figure out what paints certain artists use. I always say that the old masters would not have used half the junk, the garbage that they painted with, if they knew. We have no excuse. There's all this research being done constantly, so we know. We easily find out. The Impressionists were horrible at using organic, like vegetable-based things. You need to have a pigment, a mineral-based pigment in it for it to be stable. Anything organic is going to change. First example, original Prussian blue. This is actually the very first modern pigment. It was a color designed in a laboratory. They were trying to make it red. Oops, there goes chemistry. Sometimes you get pleasant surprises. They wound up with this beautiful shade of blue. And how they did it, and this is back in 1700s, so that's how far this goes back, you know, the development of new pigments. How they did it was they took blood and bones, they ground it up, they hoped it was going to get like this really intense red, there was some bizarre chemical reaction, and this intense blue came out. Now, obviously there's problems with painting with blood and bones. It's a little bit morbid, you have some issues. Like, now I know back then it probably wouldn't matter because you had raw sewage floating out front, but can you imagine after a hot summer like what we had, what this would smell like in your studio after a day? It would be like having a dead animal, or even worse, a dead body there. But like I said, you wouldn't notice it because of the raw sewage. So luckily we don't have that. So that was developed. Alizarin crimson. And this is one thing that I always say, like, the only reason alizarin crimson is still being sold, don't take me wrong here, is because we all go and buy it. It's like probably the color that everybody likes the most over the board. The problem is that it's very fugitive. It will change. I first heard that back when I was in school.